Okay, so last time we went ahead and we talked about quantitative data, our numerical data. We talked about measures of center, we talked about percentiles or the quartiles, and we talked about measures of spread, we talked about outliers, and then we graphed it all in a box plot. So today we're going to go ahead and look at several other ways of graphing. And we're going to go ahead and start with the stem and leaf plot. And so with our stem and leaf plot, so let me highlight this really quick. Stem and leaf plot. Also known as a stem plot. So what ends up happening is you should always start with your data values listed in order. So we put everything in order, and then we have to decide what the stem will be. So the stem usually goes on this side of the line, and the leaves will go on the other side of the line. So we've got left side for stem, right side for leaf. And what's going to happen is your leaf is going to contain your very last digit. And then the stem is going to contain all the other digits. Now, if you have really big numbers, you can go ahead and round them. So if you have 123,486, this would be your leaf right here, and this would be your stem. But that's a really big stem. And so instead of breaking it up like that, we may go ahead and round this to 120,000. And then go ahead and have 1 be the stem and 2 be the leaf. And then just say, well, 1/2 represents 120,000. And we just do that just for the ease of graphing it in that stem and leaf plot, so we can see the shape of our graph and all of that. One of the important things here is never skip a stem. Even if there's no leaf for that, we never skip a stem. So it may look like 4, 3, 2, 1, 0, and then you may have 2, 8, 8, 9, 3, 4, 5, 9, 9, 9, 2, 9, 9, 9. I'm guessing I'm liking 9s today. And so it may look like that. So we don't skip this even though there's no numbers in there. And so then always important to show a key, because we may get something like this where a 1/2 represents 120,000. So it's important to know that that represents 120,000, not 12, not 1.2, not 120. So knowing that, having that key there is really, really important for us to know what those are representing. So students were directed to a website to determine their reaction time in seconds. A random sample of 10 freshman reaction times are listed below. So we've got the reaction times, and we're going to go ahead and create a stem and leaf plot. We'll go ahead and do that over here. And the first thing we're going to do is go ahead and organize these in order. Actually, it looks like it's already put in order for us, which is really nice. And so what we're going to go ahead and do is we'll break this up into stem and leaf. So I would have a 2, 3, 4, and 5 for those stems. And then I'm going to go ahead and erase the rest of this really quick. And then what I'm going to go ahead and do is I'm going to go ahead and do the leaves in another color. So this is 26. And so I'm going to put the 6 right here with the 2 for 26. And then 28, so I'm going to put an 8 here. So that's my number 28. So the 2 goes with the 6 and with the 8. So I've got a 26 and a 28. And then I go 31, so I'm going to put a 1 here, and then a 2, and then a 4, and then a 5. So remembering that these go in numerical order, increasing numerical order, and then 44, 47, and 59. And so there's my stem and leaf plot, but I did forget something. I did forget my key. So something like 2/6 represents what? Well, numerically in my data, it represented 0.26 seconds for our reaction time. And so there we know that the 2/6 really represents 0.26 seconds. Now calculate the measure of center for the data. So this is really nice. When we're calculating the measures of center, we already have everything in order, so we can calculate mean by adding that all up. And so if we add it all up, we get 3.33. We divide by the 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. Oh, we have 9 numbers, not 10 numbers. It's not 10 people. There are 9 people. And this gives us a mean of 0.37. And then we would go ahead and do a mode, so what one appears most often. It looks like there are no repeats, so there is no mode, because there's no number that appears most often. And then we'd go ahead and go into our median, which is the middle number. So for our median, we can use this list and just kind of take one off each end till we get one in the middle, and so our median is 0.34. So now calculate the measures of spread. So we have our range, which is highest minus lowest. So 0.59 minus 0.26, which gives us 0.33. And then we would go ahead and have our IQR, which would require a first quartile and a third quartile. So I'd have to find, here's my first half. I do not include the median when I'm looking at first half. So my first half, my median would be right there. So here's my first quartile. And those numbers are 28 and 31. So halfway in between them would be 0.295 when I average them out. And then I'd do third quartile right here, and that would be 0.455. And so for IQR, I would do 0.455 minus 0.295, which would give us a value of 0.16. So now we decide if there's outliers. So again, all this stuff that we learned before, just reusing it. So to determine if there are outliers, the first thing I'm going to do is I'm going to do Q1 minus 1.5 IQR. So my Q1 is 0.295, and I'm going to subtract 1.5 times this. So 1.5 times that is 0.24, and that gives me a 0.055. So do I have any numbers below that? Nope, I'm good. There's no lower outliers, so now I'm going to look for upper outliers. So Q3 plus 1.5 IQR. So that is 0.455 plus 0.24, and that gives me 0.695. So are there any values above that? No, so there are no outliers. Okay, so now let's look at our next type of graph. Our next type of graph is called a histogram. It looks like a bar graph with no spaces between the bars. The bin width refers to how wide you want your intervals to be for each bar. You're going to determine your starting value on the x-axis. It could be the lowest number, and so this is important. It could be the lowest number, or it could be a number below that. So if you don't want to start at 33, you could start at 30. And then you're going to label each with units. So bin width would really look at how far apart do I really want these to be. And then we're going to go ahead and figure out how many numbers are in that interval. Now when we do this, everything that's from this number up to this number, but not including this one, will be listed in this interval right here. So let's go ahead and look at, we've got 25 sophomores with their reaction times, and these are listed in order for us just to make it a little bit easier. So it looks like we've got 0.25, all the way up to 0.82. So let's go ahead and start with 0.2, and we'll just go up 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. So there's our reaction times. And then we're going to go ahead and put our frequency over here. So this is the amount of numbers we actually have in those intervals. So we could have 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. So now what we're going to go ahead and do is we're going to go ahead and I'm going to try and color code this. So anything from 0.2 up to 0.3, but it cannot include 0.3. So 0.3 occurs right here. So we've got 4 numbers in there. So we would go up 1, 2, 3, 4. There are 4 numbers in this interval. So now I'm going to go ahead and pick another color, and I'm going to go from 0.3 to 0.4. So 0.3 to 0.4. And so it looks like I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers in that interval. So this is an histogram. The bars will go right next to each other. A little different from a bar graph. So now I'm going to go ahead and I'm going to look at the next one. I'm going to look between 0.4 and 0.5. And now look, we actually have a 0.5. 0.5 does not, since it's an actual number here, it is included in the bar afterwards. So we don't include 0.5 in this interval. So this is only 4 deep. 1, 2, 3, 4. 4 numbers in here. So that barrier number goes with the number after it. So now we're going to go ahead and go from 0.5 to 0.6. Looks like there's just one number. And then we're going to go from 0.6 to 0.7. We do not include the 0.7, so there's only 3 numbers here. 0.7 goes in the one after it. And so now I'm going to go ahead and go to 0.7. There's one of those. And then we go to 0.8. And there's one of those. And so that gives us our histogram, or we kind of see where the bulk of the numbers lie. So the bulk of our numbers are right in here. Okay, calculate the measures of center for our data. So our mode, what appears most often? And it looks like 0.34 because we've got 1, 2, 3, 4 of them. And then we'll have median. So we're going to look for the one in the middle. So if there's 25 numbers, I could have 12 and 12, and there's one in the middle. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is my middle number, 0.35. And then for our mean, we're going to add them all up and divide by 25. So 10.2. Oh, nope, there's not 25. There's only 24. What is with me today? This is 24. Divide by 24, and that is 0.425. And that means that my median really isn't this number here. So let me erase that. This isn't my median. It's right in between these two. And since both of them are 0.35, that means my median is really 0.35. Why do I need to mark that? Because it's really important for how I calculate my spread. Because now I'm going to have to go to IQRs. So let's start with range, because range is easier. So 0.82 minus my smallest number, 0.25. And that's going to give me 0.57. And then for IQR, now I need to find out those quartiles. So now I'm going to look at this first half. I don't include that median, which is really just an average between the two, so it doesn't matter. So now I'm just going to find the middle for these two. So 1, 2, 3, 4, 5, 6. So I want halfway in between this. So my first quartile is 0.335. And then I'm going to do my third quartile, 1, 2, 3, 4, 5, 6, halfway between these two, which is 0.485. And for IQR, we're going to subtract those. So biggest minus smallest gives me 0.15 for our IQR. So now what we're going to do is we're going to decide if there are outliers. So to determine if there are outliers, we're going to take quartile 1, and I'm going to subtract 1.5 IQR. And that's going to give us our lower bound. If there's any numbers lower than that, then they're going to be an outlier. So quartile 1 was 0.335, and I'm going to subtract 1.5 times this number. So 1.5 times that is 0.225. And this is going to give us a lower bound of 0.11. And I don't see any numbers lower than 0.11, so we're good. So then we come down to quartile 3. I'm going to subtract 1.5 IQR. And that is 0.485. And I'm going to subtract that I'm going to add, because quartile 3, we go above that, add 0.225, which gives us 0.71. And there is a number bigger than 0.71, which is 0.82. So 0.82 is an outlier. Okay, last type of graph is called a dot plot. And I love dot plots. They're really nice for our purposes. You use labeled units on a number line. So here's going to be my number line. I'm going to go ahead and label that. So for our problem, we're looking at travel time. And this is in minutes. And we're going to go ahead and label with numbers on there. You label the units for the number line. You place a dot above each value, or where a dot should approximately go. And each dot should be approximately the same size. So here, the time to school goes from 5 to 45. I obviously don't have 40 lines here, so I'm going to have to break that up. So like 5, 10, 15, 20, 25, 30, 35, 40, 45. So that way we've got room for everything. So now when it comes time to place my dot, so if my first dot's at 5, I'm going to put a dot. I really want this to be a bigger dot. So I'll put a dot there for 5. I'll put another one here for 5, and another one there for 5. And then, I got one for 6. So I'm going to put a dot here for 6. And then 7. And then 8. So maybe my dots are too big because look, I'm running out of room to fit them between 5 and 10. So let's start all over, and let's maybe make these dots a little bit smaller. So maybe 1, 2, 3, and then 6, and then 7, and then 8, and then 4 at 10. 1, 2, 3, 4. And so with them being the same size and stacked appropriately, we can really get an idea where are these numbers laying out. So 12, 12, 15, 15, 18, and 1, 2, 3, 4 20s. 1, 2, 3, 4, and then a 22, and then 3 25s. 1, 2, 3, and then a 45. So already by looking at this, it looks like 45 is an outlier. And if we were really wanted to check, we have the ability to check that. I'm not asking you to because we've already done so much already. But these are the types of things we would ask you to do. Oh my gosh, that looks really extreme all the way out there. I wonder if it's an outlier. And we could check that information. And that's it for today.